It is responsible for the math and verbal intelligence. It also is related to the abilities to think, to calculate, to learn, and so on. The last is the physical quotient, which is responsible for the body awareness and also skillful use. Do you guys have any problems until these slides? If you guys don't have any problem, I will pass my session to Chester Tan.
Okay. Okay, so right now is the part, and right now we have come to a very interesting part, which is about how does the AI learn. So in this part, instead of using the slides, I will be using a Microsoft Whiteboard to demonstrate to you guys visually like how does it learn. Okay, so it will be more appealing and easier to learn. Okay, so let me open this Microsoft Whiteboard. Okay, so in this part, actually the AI has been a very long history. So in before we used in our old AI, due to the lack of our data, since in the before in century, we have actually a very lack of data due to the not not available of having the IoT and the IT or the infrastructure stuff. So we're actually very lacking of data. So in that case, we actually use something which is called like the rule-based AI, which means that we write a lot of very if else code to code our AI, which is very not effective. For example, there's a very there's a lot of very there's actually a lot of shortcomings. For example, if this code the problem is alternate a bit, then the whole code have to change to accompany with the new problem. So it's very not effective and actually have a very small area of the apply of the application. So afterward, our human we discover that we discover that, for example, if that is actually the best way to for the AI to learn is actually through trial and error. For example, the baby they learn through the new world by using the trial and error. Like they go discover the world and they saw this thing and they learn what is that and they learn and discover and so on, and they then just like all of us, and we can learn all the stuff around us. So by using this method, they found that it's very effective to solve the problem. For example, if you know if you know the logic to solve one problem, we can actually apply it to other problems. So it means that the application is actually very wide, and if we can able to like figure out the way of implementation. So right now we have come to an era which is the modern AI, which is that we use trial and error to solve our problem. For example, I'm sure you guys have heard of the machine learning, right? So this is a very big area of the AI, and actually the machine learning is right now is very quite famous in our area of AI and in this part. So for example, I'm sure you guys have heard about the AlphaGo, right? It's actually one part of the part in the machine learning which is called the deep learning. So right now it's not the part of this, so just basically an introduction. So right now I will talk about the machine learning, which is one of the application, the modern approach of our AI to solve the problem. So the machine learning is actually a way that provide the system to automatically learn and improve from the experience or from the data, but without being like explicitly programmed, without like coding like the if else and something like that. They just give basically a generate instruction on them. Okay, so that's what. Sorry, you guys can see my whiteboard, right? You guys can see my whiteboard, right? I need to make sure that. Okay, so you guys can see it. All right, so I'll talk about the mainstream method of the machine learning. Okay, so basically the machine learning, we got three main type of method to solve the problem. The first one is the supervised, the supervised, the supervised machine learning algorithm. This is supervised, okay? And then the second one is the unsupervised one. Okay, I will explain to you guys afterward. Okay, I will first write all of this first. And the third one is the reinforcement. Okay, so basically, there are three types of the machine learning algorithm. And the first one is the supervised machine learning algorithm. Okay, so what is the supervised machine learning algorithm? Basically, it's a method. It's a method for the machine to learn by using the given data. For example, like okay, so example, we give the machine a cat. A cat is a green cat, is a red cat, and then something like that. And we want the machine to predict that is this an image of cat or not a cat, okay? So we give them a lot of image of cat, a real cat, and we can also give them the incorrect image. For example, we give them a picture of flower, okay? Picture of flower, or a picture of like dog, something else, okay? Something else. Okay, so in this case, we need to, in the supervised machine learning algorithm, we need to label all of this data for 1 or 0. For example, this is a cat, right? So we label it as 1. This is cat, we label it as 1. It's not cat, we label it as 0. This is not a cat, we label it as 0. So we give this all data. This is the label data. This is the label data. Label data. So we give all this the label data inside to the our machine learning algorithm. So it will learn like, for example, all the data inside this cat. For example, in the case of the image lah, it will learn like the pixel, all the pixel color and the pixel, something like that. They will learn all the data from inside, and then by using our different algorithm. After that, then they will learn that. They will know that which picture is the cat and which picture is is not the cat. By if we give them like a large enough amount of the data. So this is called a supervised machine learning algorithm. It's supervised, means that we tell them which is the correct and which is not the correct. So they will learn from the experience, learn by the trial and error, something like that. Okay, so this is called the supervised machine learning algorithm. So for the so for the second part, we will talk about the unsupervised unsupervised machine learning algorithm. Okay, so in this case, is unsupervised means that nobody is watching them. So in this case, with the data, we also need to provide the data to our machine learning algorithm, our model. But in this case, we don't tell them that which is the correct, which is the false one. For example, this is a 2D Cartesian plan for the data we provide. For example, this is the how to say this is the age, this is the size, something like that. Then there's a lot of data.
Sorry for disturbing. Since
Okay.
some of the attendees cannot see what you are presenting now, so maybe we investigate the problem first, so that what you present they can know.
Oh, okay. So I have to wait till you guys to find out the problem, right?
No.
Maybe now
May I
we
suggest that can you present your screen and then you use Paint to illustrate
okay.
things? Okay, thank you.
Okay, no problem. Okay. So I want to know that which part they start to not recognizing my screen. Is that from the start or what? Or they just you guys cannot see my screen since the start of my presentation? I want to know that.
from the start, they say.
Oh, from the start lah. Oh shit. Oh, that's a bit late. Okay, so wait, I'm opening my Paint. Okay. Okay, you guys can see my Paint slide, right? Is it okay? Okay, can someone answer me? The tutor, can you guys see my Paint slide?
Okay,
Yeah,
already.
yes,
So,
yes.
okay. Yes.
Okay. So you guys want me to start from the just now part or continue? Any idea? I can actually do a small revise. Any idea?
I think you can do a small revise, just a broad overview.
Okay, sure. Okay, so just now the part, okay, I will say from the, I will repeat from the start, okay? So the first, right now we are talking about how does the AI learn, okay? How does the AI learn? So basically from the old AI, the AI is, how to change the rubber, the size? Size. Whatever lah. Okay, so don't care about that. Okay, so basically in the old AI, we are using a lot of like the if-else code to solve the problem because of we don't have actually a large amount of data which are sufficient for us to learn from the mistake and try and error. So as example, the application of AI is actually very narrow and actually not applicable to a lot of areas. So right now in the modern AI, since we are in the world of the IT, we have a lot of data, basically unlimited data flowing in the internet. So we have we have a lot of data for us to train our machine. So right now, our modern approach of the AI is actually by using the machine learning approach, which means that we let the machine to learn on their own by using through the process of try and error by using a lot of data, Okay, so this is the area of AI, right? So right now there's the mainstream of the AI is actually the machine learning. Okay, so I'm sure you guys have heard about the deep learning, the AlphaGo, right? The one that play the chess and win the champion one. So it's actually one application of the machine learning, and it's actually an area from the ML. It's called deep learning. Okay, so that's an extra knowledge. Okay, so right now I will talk about like how the main type of the machine learning. Wait, how to increase the size of the rubber? Holy shit! How to increase it? Is there any way or whatever that I just delete it? Okay, so basically in this area, so right now, okay, the machine learning, okay, there are three main types of the machine learning. The first one is actually called the supervised. Okay, the supervised, and the second one is the unsupervised supervised. Okay, and the third part is actually the reinforcement. Okay, so what are these? I will explain it one by one. Okay, so the first one is actually the supervised. Okay, so what is the supervised machine learning method? Okay, so the supervised meaning means that it's being watched by someone, right? It's being supervised by someone, right? So in this case, the machine actually learn through by actually using a lot of data, which is label one. Learn through by using the label data. Means that all the data given to the machine learning models are actually label one. For example, if I got a machine learning model, which I want this model to differentiate between is this a image of cat, or is this an image of or not the cat? Okay, you want to like classify is it an image of cat or not the cat. So we given the model a lot of the data. For example, given an image of cat, this is a cat, right? And also given of like flower, we can give them the wrong one and the correct one. Okay, so this is the people. Okay, so if given the enough amount of the data to the machine learning models, it can actually learn through by using a lot of the characteristic of the data given. For example, the learn through the pixel, the color, something like that. Okay, and all the data are actually labeled, right? This is the cat, so we label as 1 and 1. This is not the cat, label as 0 and 0. So by through the trial and error, they can actually learn through all the images, and they can actually find out if you provide a new image of cat, they can actually predict whether it's a cat or not a cat with a very high accuracy if we given enough sample of image and good quality of image provided to them, and which are all labeled. So this is the supervised learning, which that the machine learning models learn through by the label data. Okay, all the data are labeled. And the second one, and the second one, and the second one, okay, and the second one is actually the unsupervised learning model, unsupervised machine learning method. Okay, so in this case, the machine learning model actually learn the data by you. So learn the data, but the data given are actually the unlabeled one. The data are just given to the machine learning models, and all other are unlabeled. So meaning there's actually a lot of data. For example, this is a Cartesian plan. Okay, so for example, we have a 2D data set, and this is the age, and this is the size. Okay, for example, and we have a lot of data at here. Okay, a lot of data at here. So for in this case, for example, our unsupervised machine learning algorithm will actually try to find out the pattern existed within the data set. For example, this is to predict the how to say for example the tumor, for example tumor, and we can see that there are actually two group data, right? So they can actually they can actually find out like the pattern of that, and we can categorize something like that. So actually basically this is actually a one way to find out the pattern existed within the data. Okay, and then we find out the pattern, and then yeah, they describe the system now. Okay, the way they find out the hidden pattern of it by using this supervised machine learning algorithm. And the third one is actually okay. And the third one, okay, and the third one is the reinforcement machine learning algorithm. So this is a learning method that we, for example, okay, we got an agent, for example, okay, so this is a path. Okay, this is a path. For example, this is a path. That's an agent at here, and the mission of the agent is to reach the goal at here. This is the goal. Okay. So in this case, if we want to like find out the least step for the agent to go to the goal, and without like activating the trap, for example, we got the fire at here, we got the trap at here, we got a trap at here. So we need to find out the least step for the agent to reach the goal. Okay, by using the reinforcement learning algorithm. So this is they say the best way to do this. For example, you want to achieve this by using the reinforcement machine learning algorithm, we can actually we actually let the model for the agent to interact with the environment by producing action and discovering the error and the rewards. For example, if we reach the goal, then we will have a reward like +1, for example, and we reach the trap, we have the punishment by -1. Okay, so in this case, the agent will try to like find out the way which they can reach the goal with a minimum step, and to avoid the trap, all this trap. So it's just an example lah. Okay, this is just an example. So by using try and error, they can at the end they will find out that the least error and the highest marks one. So then they can achieve their mission to reach this goal by using the least step lah. Okay. So this is actually what an reinforcement learning algorithm is. They just go through try and error. For example, they go through error, and they will restart and error and restart, and they find out all the possible way, and then they will find out the best way to reach the goal by using inside here there's actually quite a lot of the algorithm. For example, like counting the max, or the list of the score or something like that. Okay, so this is what reinforcement learning algorithm is. Okay, so these are the three main types of the machine learning algorithm. These three. Okay, so that's all for my part. Okay, so let's have a few minute rest for you guys, and later will be continued by the other tutor for the remaining session. Okay, that's all. Thank you.
Okay, so is everybody back? We gonna wait for another 1 minute to wait for the rest. Okay, so now it's 8:44. Okay. Okay, so I think I can start now. So basically, artificial intelligence is mostly the use of mathematics. Is a great amount of artificial intelligence is founded in appropriate use of mathematics to implement logic. For example, we use matrices, multivariate calculus, linear algebra, probabilities, functions, vectors, and others. Mathematics is very essential towards the path of understanding artificial intelligence, and more importantly, to utilize its functionalities for certain purposes. As said before, some examples are the use of algebra and matrices in neural nets and image processing, the use of the graph in classifiers, which can classify, like, for example, the objects, and the use of vectors is and the use of mathematical equation design in basically all aspects when solving a question or problem. So it's very important that we need to use mathematics in artificial intelligence. So for the next one is reasoning, goal trees, and problem solving. In artificial intelligence, we use logic and interpretation of multiple definitions and occurrence to form concepts. Thus, artificial intelligence understands how we think and talk, how we learn, and how we see the world around us. This part is more practical, in-depth, detailed demonstration in how to mimic the understanding and intelligence through mathematics and programming. Basically, it means that artificial intelligence needs to use mathematics and programming to understand what human understands. Next is the integration calculator program of James Slager, which is the dawn of the time, yet pretty smart program. Is basically a one lecture course of artificial intelligence. Imagine an artificial intelligence is being tasked to solve every integration problem given to it. The approach is to have a program that uses safe and heuristic transformations to turn the question to simplest form. Here we have a table of transformations under two categories, safe and heuristic. After we put the integration problem into the program, it starts to performing the order transformations. The transformations here means that the mathematical equations or anything that relate to mathematics and programming. So the way the transitions will be represented is via a goal tree, also known as a problem reduction tree, and also known as a tree because it has n and all operators which can perform functions on the nodes. So first, we input the problem, and then the artificial intelligence will turn this into the root node, and then starts the process of simplifying it. We call this process as the problem reduction. We also have the list of the safe transformations. These transformations are valid for all situations and always work. And we have the second category, which I just said, is often helpful, but doesn't necessarily work. We call this as the heuristic transformation. After forming the tables, we start the procedure of simplifying the problem. So here we can see list of the safe transformations. And this is the examples of the safe transformations. The first example is minus of integrator of function x is equal to integral of minus function x. So this is all the mathematical equations. And here is the second category, which is the heuristic transformations. The first example is transformation from trigonometric form to polynomial. So as we say that heuristic is is very helpful, but maybe not valid for every situation. Okay, so we are going to go trees and rule-based expert system. Imagine an AI is tasked with understanding the semantic of a passage of text, like a book, and we wish to program it so that it can interpret the text, or we want the artificial intelligence to classify unknown variable based on the given data, extract statements and concepts, and be able to answer questions about itself and its choice. And let's call this the self-aware program. The artificial intelligence will actually break down the passage and form a tree graph of nodes under templates and link the nodes based on the actions taken by the passage characters. Like the example, how Macbeth murders Duncan. And in this example, it will actually like how we learn languages. Maybe it will classify the Macbeth into a noun, and then classify the murders into a verb, and the Duncan into a noun. So it will form a tree into it, a tree graph of nodes. So this is what artificial intelligence do. After the tree is formed, it will traverse inside the graph and find the predetermined concepts from the passage and understand the text. So here we use a formation called rule-based expert system, which is how we use artificial intelligence to interpret concepts based on given data and how it classifies the result. Like giving characteristic of an animal and having AI say that what animal is. Later I will give an example. So now we can see this example. Like here we have some characteristics, and artificial intelligence will actually turn this characteristic and then move to the answer. So now we have strong stripes, orange claws, sharp teeth, and the forward-facing eyes. So it will actually classify it into a tree. And then to get the goal, the answer of what the animal is, we use the forward chaining rule based expert system. And to get the answer why the answer is tiger, we use the backward chaining rule based expert system. So the forward chaining is basically if we have the strong stripes, orange, it will basically give the answer tiger. And then the backward chaining, if we have the tiger, it will basically know that it is strong stripes and orange. So for the next one is constraint branch. It is also known as human learning, and it is split into two branches of learning, which is one-shot learning, which is we learn something definite from every encounter or interaction. and the explanation based, which means our intelligence is derived from our abilities to tell stories, which is extremely important. Like how you may ask, when we are doing a problem or teaching or communicating, we actually uses storytelling ability, which is the teacher basically tell a story, which you learn something definite from one-shot learning and understand it through the flow of the story. So this is what humans do. We can learn things. We actually learn things through storytelling, and this is what differentiates us from artificial intelligence. And then we are going to talk about symbolic learning completion. So how our way of thinking is highly dependent on the symbolism, as our way of thinking is based on symbolic thinking. We said Java also inherits this way of thinking from us humans, as it creates the representations of real-life models to solve problems. Same with other science. The blueprints of machinery, anatomy, and atomic models. We use model representation in every attempt of doing a problem or simply exploring the uncharted through cognition. And we can also learn through storytelling, which is how we understand a model and learn from it. And here comes the completion of symbolic thinking. The humans use storytelling to illustrate a problem that is solved through creating a representation of problems model through symbolic thinking. So basically, it says here we use the storytelling ability to solve the problem, as we illustrate the problem like thinking in an image. So far, do you guys have any questions? If no, then I continue. We may thought the artificial intelligence is omniscience. What omniscience means is knows everything, but truth is artificial intelligence is like us, like the human being. Artificial intelligence need to learn before they know and improve itself through practice. And from time to time, artificial intelligence learns mistakes and avoid to making them again. So artificial intelligence looks like omniscience, but we actually need to give the data before it learns, the data for artificial intelligence to learn. So basically, it only looks like omniscience. Here is an example of, I think everyone know that AlphaGo is the chess player of artificial intelligence, have defeated many top Go players, but it hasn't always ended with 100% victory. The game between AlphaGo and South Korean professional player Lee Si-do ended in 4-1. And the AlphaGo won the first 3 games. The Lee beat AlphaGo in 4th game. However, Lee didn't defeat AlphaGo in the 5th game. So AlphaGo has the more, I can say more successful algorithm to beat Lee in the Go chess. How can artificial intelligence sweep the human top players? Scientists are trying to apply what we know about the ways humans learn to machine learning. So artificial intelligence has developed an algorithm which makes it possible for artificial intelligence to learn from its own mistake in the same way baby does. There are new technology called hindsight experience replay allows artificial intelligence to review its previous actions when completing a specific task and makes artificial intelligence become more and more perfect. So the technology basically can tell the artificial intelligence in learning, and it's basically about mainly about the mathematics and algorithms. Okay, so now we are going to talk about artificial intelligence understanding text. A simple project has been demonstrated into university course is the artificial intelligence understanding the Macbeth story. Same as human, it analyzes the text, segments it, and turns it into a connected graph. So like just now I said that it classifies the text into many groups such as the noun and verb. How does it understand the text? It's basically using interpretation, meaning it will use classify as illustrated to understand the emotion and thoughts. So besides noun and besides classifying it into verb and noun, it also uses a big database to know the definition of murder and kill, so that the artificial intelligence can understand what the sentence means. Now there's a graph of the Macbeth story. We can see there's an agent, victim, action. This is the one that the artificial intelligence classify into. And then they are combined with the arrows. And then we have the kill, murder, and the black arrow points to property of being dead, means that Macbeth murdered Duncan, so that Duncan is dead. So this is basically what artificial intelligence do. What is artificial intelligence in gaming? So in gaming, it refers to responsive and adaptive video game experience. These artificial intelligence powered interactive experiences are usually generated via non-player characters or NPC that acts intelligently and creatively, as if it is controlled by a real human game player. Artificial intelligence is the engine that determines NPC behavior in the game world. So now we can have the example. The games has been used for decades as important to test and evaluate the performance of artificial intelligence system. And for example, a real-time strategy game, StarCraft. AlphaStar is a artificial intelligence player from StarCraft plays with deep neural network. So what the technique used is a deep neural network, and it defeated the best human player 5/0, and Go artificial intelligence AlphaGo, the next vision of AlphaGo. It developed itself by playing with itself and only have only 3 days self-training. AlphaGo 0-bit is predecessor AlphaGo, the second vision in 100 win rate. And then after that, after 40 days learning, the final vision AlphaGo master lose its #1 title. So artificial intelligence in game is not just only against the player, but also provide the player a immersive experience. For example, the player can interact with the artificial intelligence NPCs, and the NPCs will respond to what happened in the environment. like player don't take shower for a long time, the NPC will stay away from the player, and if the player keep following an NPC, it will act like a normal people, be scared and warn the player to stop. An NPC in the game also have their schedule. They are not always wandering on the road. They have something to finish. So it's not like a robot that only program what to do, but the NPC can interact with a real human player. So for the summary of session, I'll pass it to lecturer to give the summary. Are you there?
Yes. So this is the summary of this session. The artificial intelligence basically refers to the simulation of human intelligence in machines that are programmed to think like humans and also are able to mimic their actions. And it is about thinking, perception, and action in a broad and connected manner. AI also improves the life quality and raise the productivity in our daily life. They uses different types of algorithms to complete its tasks efficiently and also able to do self-learning to enhance itself to do better. Intelligence can be divided into three main types, which are practical, analytical, and creative. So there are 4 bounds of human intelligence, which is intelligent quotient, IQ, which is all about the calculations, and then the abilities to learn. While emotional quotient, EQ, is all about managing emotions and relationships. The spiritual quotient is responsible for the inner wisdoms, while the last, the physical quotient, is all about the body controls and so on. A symbolic AI systems can be realized as a microworld. For example, blocks world. The microworld represents real worlds in computer memory. Next, we'll move to the machine learning. Machine learning is an application of AIs that provide the system the ability to automatically learn and improve from experience without being explicitly programmed. Just like the Chesterton said, the explicitly program is the else if and else statement. This is really not effective at all. So by providing the machine the ability to learn, it will be much more effective, and then it will the program will run more smoothly and more intelligently. And machine learning mainly focuses on the development of computer programs that can access data and use it to learn from themselves. Next, human learning is the one-shot learning that learns something definitive from every encounter of interaction. Our learning is based on explanations, unlike the machines, which we need to train to process great masses of data and the powerful computers to process them. Their learning is what we call bulldozer computing using neural nets, boosting, and also nearest neighbor learning. Next, logic is a systematic study of valid rules and principles of inference. More broadly, logic is always the analysis and appraisal of arguments. In AI, we use logic and interpretation of multiple definitions and occurrence to form concepts, and thus allowing the AIs to understand how we think and talk, how we learn, and how we see the world around us. AI can make mistakes just like the human being, and AI are able to learn from mistakes to make itself become more perfect by avoiding make them again. By using some constraint-based models, AI can understand text by dividing sentences into several parts and analyzing them. And last, The game is an important way to test and evaluate the performance of artificial intelligence systems. There are many kinds of NPCs in the game that act intelligently. So in conclusion, why is AI a growing science? Artificial intelligence seems to be on the tip of everyone's tongue these days. It is becoming widely used and even appearing as one of the most in-demand areas of experience for job seekers. Data also shows that the use of AI in many sectors of business has grown by 270% over the last 4 years. And people are increasingly relying on electronic devices that promote the development of AI. Also, the higher productivity and less time cost. As humans invent car to replace walk, they will invent AI to replace the driver. So that's all for this session. Any questions? If no, I will stop presenting now and I will upload some illustrations for today's lessons, which can help you guys to learn better, I think.
Okay, guys, thank you for joining for intro part one. Don't worry, we'll touch more on this in the following session. Okay, so if you have anything that you didn't understand, no worries there, and we will have a content creator personally and come and do this very quickly. Yeah. So this session was a session, a pretty important session. Okay, it's about what intelligence is and how to mimic it. So basically, the AIs that we have today are trying to mimic how we think in a smart manner and same as us, they're imperfect. So they try to learn from their mistakes. The thing is that they have a progressive learning methods. Okay, we say progressive because every single time that they learn something, they still have something that they haven't tried. So they try it, they fail at it, and they learn from it. Okay. So that's how AI is basically learn using machine learning and basically learning algorithms such as nearest neighbor learning, which is also inside the PowerPoint. We will touch on it in the following sessions. So basically, we have different algorithms for learning, different ways to improve the functionality of an AI, like boosting. This we have in the learning methods as well. And it always comes down to what's the difference between the way that AI thinks and the human thinks. So the thing is that AI doesn't think. AI mimics thinking through smart algorithms, right? Even if you think, even when AI perceives environment, even when it tries to understand it, it doesn't really it's not really aware. So that's really the root and the origin of why we say AI mimics it. It's not really intelligent on its own. So basically, the difference between the way and AI. So we come to the conclusion that AI isn't intelligent but mimics intelligence, and that's why it's using artificial intelligence science. It's allowed us to understand the way that we think a bit better. So we've been able to program algorithms that basically try to mimic a branch or a part of how we think. Smart learning always improve. Okay? So that's AI learning. That's how AI works. But before that, before we were able to basically program AIs, before we were able to improve them, write algorithms for them, we needed to understand how we thought, how our intelligence works. Okay. So this session basically brings everything from part one, the main concepts together. Okay. is AI auto-created, or do we have to, let me see the chat. Is AI auto-created code, or we have to code ourselves to generate the probability of them? So basically, Carson, and we use databases. So in the PowerPoint, if you look at it, and we have the nearest neighbor learning again, which has two main issues to consider. First one is a data spread, which is when data is spread only in one dimension rather than two. Don't worry, we will teach you guys everything from this PowerPoint the next session in detail. I will personally come and explain to you guys. Okay? So no worries there. This was just basics. And basically, the data is always, okay, Carson, is always produced by us. So imagine this: you want to use, you're the CEO of a company, okay, and you have been in business for about 10 years, so you have some experience and some data, and you want to predict how well a decision you're thinking, an executive decision you're thinking about, is going to have either a positive effect, financial regards, or a negative effect. So you can hire an AI expert to come and put the data you have from your background, from the environmental trends, from the audience you're targeting, inside the prediction system. And then based on the algorithm designs, the AI will actually predict the future. So as challenging and scientific in sci-fi it may sound, it's actually doable, pretty doable. We actually use it a lot in the business, especially in product design, and to basically have a bit more understanding of the audience's appeal. Okay, so we've come so far to be able to even foresee the future, not really in detail like realism, like what's going to happen tomorrow, but in specific aspects like how well is this product going to do, how well is this show going to do, how long before a customer comes back to us. So you can use AI to predict certain outcomes before they happen and basically have time to improve them. So yeah, you have to produce and give the data yourselves. Okay, so where was I? All right, so basically that's how AI works. But to understand AI a bit better, you need to understand how you're intelligent. In the PowerPoint, we will explain to you guys that our mind, our brain is symbolic. What does that mean? It means that you have a symbolic thinking. Okay. And if you look back on part one, you remember that we said object-oriented programming is the way that we use symbolism to represent models of the real life. So that's basically how our mind works. Java inherits that from us. Basically, the humankind, human brain uses symbolism to understand and explore the world around it, to be able to use symbolism to solve problems, overcome challenges. So our mind has symbolic thinking. Okay. So being built on that, we also have a certain abilities. That's the origin of our intelligence. Okay, that's how we've been able to evolve past any other creature. That's how we've been able to basically solve more problems in more depth. Okay, so the symbolic learning completion slide gives you the conclusion to how our brain works in one very short and brief sentence. Humans use storytelling to illustrate a problem that is solved through creating a representation of the problem's model through symbolic thinking. In this short sentence, in this short basically code, you can understand how human intelligence works. We have three highlights: our ability to tell stories, our ability to represent models, that's our logic approach to solve problems, and we do all of these through symbolism. So that's how your mind works. That's why you have mathematics, you have physics, you have languages. That's how you communicate in written sense, and in even in speaking in a spoken language, you have phonology. So that's how you basically use symbolism to explore, communicate, solve problems, etc., etc. Okay, don't worry. In the next session, we will explain all of this to you in more depth. Okay, so that's how our brain works, and that's how AI mimics this sort of symbolism to mimic a sense of our intelligence in its algorithms as well. So that's that. The highlight of the session was to bring a loop to the everything that we touched from the first session of part one to this session. It's all connected, okay? everything we've taught you up to now, the flow, it's all connected. At the end, you're going to see how far you've come, not just in the programming slide. Even if you're not going to study programming, the last lesson of our course, which will convey to you from the flow of the session, it's going to be very helpful for you in solving any question you might have. It's going to help you to solve any problem that you encounter in an intelligent sense. So you're going to get smarter after this. Any question, guys, about the what we went through this session? So basically, our highlight was machine learning. In the next session, we will work more on this same PowerPoint, but we will do more in detail. Okay, so because it's a heavy in content one, we wish to give you guys more time to read it yourselves. Then we will do the comprehensive session ourselves to give you more highlights. So no worries there. If you didn't understand anything, don't worry. The next session will cover everything you missed. Don't worry about it. Any question, guys, about the things that we went through, or anything you'd like to ask about AIs, about intelligence, anything? Did you guys like the session? Did you guys enjoy the PowerPoint, the content? Was it understandable to you when you were reading the slides? Basically, the goal of this PowerPoint session is to give you guys a sense of how your brain works and how by understanding that you can solve more problems, even the complex ones. Later on, you don't even have to solve problems yourself. You can program applications that simulate that, like the integration of James Lego. It basically, funny thing, it was done in the 1960s by a blind master student, blind not in a literal sense, in a metaphorical sense. He wasn't really bright, but he was able to program this integration solving program that beat all of the MIT freshmen, all of them, even expert mathematicians in the integration program problems. Considering the computer that it was designed on and was pretty limited, pretty constrained, every kilobyte mattered to them, and it wasn't very strong. So the algorithm was pretty smart for its time. So using the transformations table, the safe transformations, and the heuristic ones that we will explain in the following sessions, and we shed some light on in this session, he was able to solve any problem from the last decade of MIT's integration finals of calculus 1801 in a matter of seconds, all of them correct. He beat all of the MIT students with just a single program. So you're going to be able to do the same thing. Basically, that's how programming helps people in their problems. By programming smarter applications, you're going to make your job and life a bit easier and be able to do them with near zero error rate. Okay, so that's why you learn AI. Programming is static. The thing that you learn in part one is that your program doesn't learn. Your program is able to only execute whatever you've programmed it to. Okay, it's as smart as its program. Okay, but AI is able to learn. So imagine the AI makes a mistake in the first run. If you run the program again and do the exact same inputs that you gave it, it's going to be better at it. Why? Because it learns every single time it does the same movement and comes back to the same movement. It refers to the details and information it got, whatever it learned from that experience, and gets better at it. So next time it comes to doing the same thing that it has done before, it's going to be better at it. That's actually something, again, related to nearest neighbor learning, which, again, we will explain in the next session. So this session was just a general overview of what AI is, what machine learning is. In the next session, we encourage you to read the PowerPoints once yourselves. In the next session, we're going to teach you guys how to basically utilize AI, how to understand it better, and the classifier program, the one that it had the strength and stripes. You're going to be able to program it yourselves. We're going to teach you in AI coding 1. Any question, guys, about the session, about anything in general, not even about the session? All right then. And thank you for joining us. If you have no question, guys, and have a nice night and have a nice weekend.